Good morning. My name is Jim Bottom, and I'm here to do two things. Your key card's still up here, too. One is to introduce Dr. Loretta Moore from the NSF, and the second is to get her presentation run. It looks like we got that done. It was a loose HDMI cable under the down here somewhere, so watch where you step up here. Dr. Moore comes to the NSF from Jackson State University, where she is a faculty member in computer science and also was more recently the vice president for research. And we're going to get an introduction to what is now the established program to stimulate competitive research. When I was at NSF, it was the experimental program. So now it's the established program. Dr. Moore?
Good morning, everyone. It's my pleasure to be here. I was telling my colleague I was nervous. I think for the past 7 years I've been in upper administration, and now I'm back to where the CI professionals and computer scientists, and so it really feels good, but I was like, okay, what has changed and what needs to be changed, and how can I help being on the administrative side, being at the funding agency? So I know that most people are familiar with NSF's mission of fundamental research. We want to transform the frontiers, innovate for society, and perform as a model organization. I've been really impressed with the effectiveness and efficiency of everyone at NSF with such a large rotating pool. And as an IPA, I would like to encourage you all to apply for a position and come spend a year or two at NSF. It's a wonderful organization, helps you learn how the wheels turn, so when you go back to your organizations, you can be even more effective. And I know that Manish yesterday said he had open positions, but I have open positions also. I would love some CI professionals, so don't forget about me. And so, you know, NSF's budget is about $8 million and about 12, I don't know why I can't see, that's a problem. We got about 12,000 proposals and 350,000. That one I can't see. No, not enough. You know about NSF. You know about the numbers. You can find it out on the website. Excellent organization. I know for at least computing funds, most of computing fundamental research. There's not another agency that supports computer science. So we're delighted that NSF supports the organization. This is sort of the organizational chart. EPSCoR program is in the Office of Integrative Activities, and you heard yesterday about some of the things that office does, and it works across the foundation, which is really beneficial, so EPSCoR can touch every single aspect of research in the directorates that we support. And we are there with the evaluation component and with the integrative activities, so really good placement for EPSCoR. So EPSCoR, the big picture, is a jurisdiction-wide partnership. Federal, state, and private sectors. Governance is by a statewide steering committee. The work that's put forth in the Track 1 proposals have to be aligned with the state's jurisdiction science and technology plan. And so we were talking yesterday about each state also needs a cyber infrastructure plan, and maybe we can align the CI plan with the state's S&T plan so we can more effectively understand what each state or jurisdiction needs. And so they're team-based, very complex, cross sectors and cross institutions. So EPSCoR is designed to enhance the research competitiveness of targeted jurisdictions, states, territories, and Commonwealth by strengthening STEM capacity and capability. And so we have an ongoing effort to really define what research competitiveness is. We're not trying to compete one jurisdiction against the other, but what components make up research competitiveness. It's not just how much money you bring in or how many awards you get or what category you're in terms of a ranking, but what really defines research competitiveness of a jurisdiction. We catalyze research capability across and among jurisdictions, and we're looking to how you can define that. We established STEM professional development pathways. This is from K-12 all the way to faculty ranks. And we looked to broaden participation of diverse groups and institutions in STEM, and it looks like Montana is doing a great job with that. And so we affect engagement in STEM at national and global levels, such as the data that's collected, we want to share it, we want to disseminate the information. And we also look to impact the jurisdictional economic development. So our Track 1 projects really have a broad range. And so how many EPSCoR jurisdictions do we have here? I know we have Montana State, we thank you, and Montana, shout out. North Dakota, South Dakota, Oklahoma, Arkansas, South Carolina, I heard another, Maine. Okay, we have a lot of people here, so we appreciate you being here, and hopefully you can work with me as in my role as section head to understand how EPSCoR can help the jurisdictions, especially as we talk about joining the National Research Platform. Okay, so here are the jurisdictions, and we heard a lot of them shouted out. And yesterday we talked about sort of like the ranking in terms of access for many jurisdictions. I think 5 of the top 10 states were EPSCoR, but then a large percent of the lowest ranked states in terms of access were EPSCoR states. So we need to work from both ends and get those that are doing well, help those that are not doing so well. And it seems as if a lot of that partnerships and collaborations are a part of what you do here. So EPSCoR has several investment strategies. We have the research infrastructure improvement, which is the RII, and we have tracks 1 through 4, and it's about 80% of our budget. And we support physical, human, and cyber infrastructure within academic institutions across each jurisdiction. We have the co-funding mechanism where we work with NSF directorates and offices, and we have outreach and workshops. And the co-funding is about 20%, and the outreach and workshops about 1%. So EPSCoR's funding represents about 2.7% of NSF's overall budget. But our goal is to give you the capability so that you can apply for that other 97 and a third percent of funding and be more effective in obtaining it. So as you'll see, our FY18 budget is approximately $170 million, which is the highest that it's been in the past couple of years. And we definitely invested that across the board in co-funding, with outreach and workshops, and with the Research Infrastructure Improvement Awards. So our Track 1, these are the $20 million grants, and they kind of set the stage for what's going to happen in a jurisdiction over 5 years, what will be a particular focus areas. And these are very exciting projects. The fundamental is the research, but they have education component, workforce development, innovation, so the full spectrum of everything that we talked about. So very talented people. Do we have any Track 1 representatives, PIs or co-PIs or other leads for Track 1? So we have that. We also have our Track 2, which is, so Track 1 is within a jurisdiction. Track 2 is to sort of promote collaboration across at least 2 jurisdictions. And those are $1.5 million a year for 4 years. And so you find something that's a common problem or a problem that you both can share in solving, and you work toward those. They're typically aligned with NSF strategic plans. So we've had Genome to Phenome, the Brain, and Fuse, and we can't yet announce, but we have a new initiative that I think you all will be excited about as the focus for Track 2. And we should get awards announced within the next couple of months, and you'll get that solicitation out as well. So Track 3 was sort of piloted in FY13, and it's sort of is similar to Includes. It came before Includes, and so now we're looking at what should EPSCoR do in terms of broadening participation? We have the Includes projects, we have jurisdictions with Includes, so what else can we do? So I'm coming to you with more questions than answers. And Track 4 is a new program in FY17, and I've been reviewing those lately, and there's some really exciting grants. So up to $300K over 2 years. for for non-tenured faculty. So they could be tenure track or they could be research faculty and non-tenured track. And it's to help promote their careers. So we're still building the base, building capability. And so you can have more than, I think there's a limit, but you can have more than one person from each institution. And their partnering, it really gives us a chance to use EPSCoR funds to allow these faculty members to partner with people not necessarily in EPSCoR jurisdictions. So for whoever the leaders are in their field of research, they can go there and spend 2 summers, or they could split up their time some other way and really help them to go forth. Many of the things that they are proposing are very innovative, very discovery. It's not sort of like the routine of what you expect. So we're real pleased about that program, and we bring in ad hoc people. If any of you have served on the committee, we thank you for your service to look at it, and we also have a panel. So co-funding is what we do with NSF colleagues. So if they review a proposal and it is found to be meritorious, it may be that in highly recommend there are 4 proposals, but they only have money for 3, then they'll come to us and say, hey, we have this great proposal. It happens to be from an EPSCoR jurisdiction, and we may have already funded one from an EPSCoR jurisdiction. Can you co-fund with us? And so we really like being able to reach out and reach additional faculty members through the supporting of co-funding. Now, we have priorities within co-funding, so it's not automatic that if you're in an EPSCoR jurisdiction that you will be funded. We look for new PIs. It should be collaborative and multidisciplinary, trying to encourage those items. And synergy with NSF priorities for the current fiscal year. They must have broadening participation. They can propose instrumentation, and also building that pipeline with K through 12 or undergraduate students. And we have workshops and outreach, and we talked a lot about workshops on yesterday because the question was posed, what are the CI needs for the EPSCoR jurisdictions, and how do they differ from other states? And that was what I tried to find prior to coming here, and it's really not clear. So we got a team that's working on a proposal for EPSCoR workshop to really look at cyber infrastructure and what are the things that you want to measure to determine which jurisdictions need support and which may be far on their way. And so we hope that that will come. And we're also concerned with minority serving institutions, and I met several people yesterday, and predominantly undergraduate institutions having access to the network platform. So what are the things that we can do in EPSCoR at NSF to ensure that everyone has access to the platform? And outreach, if you want to bring somebody to your jurisdiction to talk about one of the new programs, they can come to us and we can help fund them to visit with and talk with you. This is sort of our proposal success rate. Overall, NSF is at 23.2 success rate. And right now, with these years, EPSCoR was about 20.6%. And that's not bad for these jurisdictions that we're helping to develop their infrastructure. So we're very pleased with that. And just some alignment with size, with your platform, supporting cyber infrastructure to enable and accelerate discovery and innovation across all disciplines is something we're going to focus on. Broadening interdisciplinary collaborations across universities and jurisdictions, and building a tech-savvy workforce with the skills essential for success. And so those are some of the things that we're looking at doing, and we really look to you for the answers as to how we can go about being effective for the jurisdiction. Thank you.
Any questions?
How many workshop proposals are we going to see?
Okay. Yeah. Thank Loretta again. And you're going to stay up here. And Loretta's going to stay on. Could the rest of the panel come up now for the campus needs panel? As Loretta was going through that, it reminded me we got an ROI Award at Clemson. Oh gosh, I forget how many years ago. Jill would know the when we got it, but that we funded a staff member through that who became the prototype for ACI Ref, which you heard about the last couple of days. try to follow Wendy's model yesterday, and everybody good. So I'd like to introduce our panel for the what do campuses need for NRP, and we're going to definitely work to keep within 7 minutes apiece for each of the panelists so that we can have conversation with the audience. First up will be Jeff Weekly from UC Merced, founding member of PRP. Loretta will be back to talk about the needs of campuses, and which she's certainly familiar with at Jackson State, what is needed at schools in EPSCoR states to become part of the NRP. Josh Sonnestrom will come up and talk to us about another founding member from Santa Cruz. Will talk to us about their experience. And then Dan Stanzione from TAC, who has certainly been very successful there, but more importantly, he's a Clemson alum. And comes to football games, good loyal alum. And Dana Bronson will wrap it up. Dana's from Oklahoma State, where she runs cyber infrastructure, and she also is a co-lead of the Campus Champions program, which you heard a fair amount about yesterday, and recently is helping with Tom Cheatham to drive the Consortium for Research Computing on Campuses, which you may mention too. So, Jeff, I hope I got yours up here. No, I don't. You could probably find it better than I can. You got it.
Thanks. Thanks, Jim, and thanks to the organizers for letting me take up a little bit of oxygen today. See if we can go this full screen. There we go. A little bit about UC Merced. It was established in 2005, and it's sort of branded as the nation's first new research university of the 21st century. We only have about 8,000 students, but we're growing. It's projected to be about 10,000 by the year 2020. We're located 2.5 hours from San Francisco Bay Area, and that's a blessing and a curse. The biggest thing happening on campus right now is we're adding $1.3 billion in new buildings, more than doubling the square footage of campus. It's an amazing transformation. And as I said, we're going to double by 2020 and then double again by 2030. So our challenges are all related, understandably, to growth and newness. I came to UC Merced in 2016. I had spent about 16 months down in New Zealand working with Steve Cotter at the National Research Network down there as their science manager. But before that, I was founding faculty of the MOVES Institute at the Naval Postgraduate School, where I did research in virtual environments, virtual reality, advanced media. And I found myself painted into an infrastructure corner over the years. The stuff that I was doing required more and more network, more and more computation. And that's how I came to this community. So I started at UC Merced in 2016, and it was literally a greenfield opportunity. It was a greenfield, and they were just building the buildings. So I kind of was able to set my own goals and stake out what it was that I wanted to accomplish there. Just very broadly, I really wanted to build the kind of cyber infrastructure that leveled the playing field for our researchers on campus, and allow them to pioneer innovative applications through services across a very diverse set of use cases. And I was talking with someone earlier on today, and I said, it's really surprising the plot twists we're seeing on campus with who needs this kind of infrastructure. It's not just the physicists and the astronomers anymore. It's the humanists, it's the filmmakers, it's the social scientists. So I'm really trying to democratize this kind of technology for people. And more than the technology alone, it's really about building human capacity across campus to enable these advanced CI-supported research efforts. Not only capacity in my staff of one, but also in my cohort in the IT department, and importantly, the faculty, and especially importantly for the graduate students, our future faculty. So in 2016, we were awarded a CC Star grant to build a Science DMZ. And of course, this is very equipment heavy. We bought a dedicated edge router. We worked with the networking team to reconfigure the topology near the edge to support this extra path. We lit up our CalRen HPR connection to Scenic, our 10 gig network that we had, but we never used. And we even deployed a few 100 gig network cards to sort of future-proof that infrastructure. We serve all the main academic buildings, and I had a conversation last week about extending the Science DMZ to a building where it hadn't existed before, and the conversation lasted about 15 minutes, and this is with the network engineers, and we said, okay, we'll do a layer 2, and from the BDF back to the telecommunications building. And if you pay for the Cat6 cable pull to the lab, that's good. We're good to go. 15 minutes. So your mileage may vary on that. Now, the challenge there is that it's going to take me about 3 months to pull this off because we are so constrained on our human resource that, yeah, I can get the contract executed, but actually getting the attention of the network engineers, even though they've agreed to it, I continually have to push. So that's always a challenge. We've sweetened the pot for them. We said, we know that you're interested in exploring IPv6. We can make the Science DMZ a test bed for IPv6 for you. And that makes it more, maybe less of them doing me a favor and more, mutually beneficial. And I also have the advantage that I'm building on top of a fairly new network. The network was completely refurbished over the last 24 months. So these conversations can be pretty easy. But it's still, non-trivial to do this. So the technology is fairly well understood, and we know how to pull cable, and we know how to patch a network switch into a VDX, but it's the human capacity that's really, really hard. So this is what I focus most of my time on our campus doing. That's removing technological roadblocks for people, and that may be teaching them tools and new things. It's building repeatable workflows, fostering touchtone or projects that we can really get excited about on campus, like our visualization lab, the Wave. It's encouraging those PRP partnerships. So every time I get asked to help write a grant, I always stick in a paragraph about PRP, and we talk about how PRP can help this project. I want to uncover those force multipliers, and that means those things that sort of help other things shine and remove barriers. And we always have to design these systems in ways that are scalable, sustainable, and properly resourced. So the demand is almost unlimited. And so one of my biggest challenges is having to pick the kinds of projects that I know that I can support. Even though it's a great idea, I really want to be able to say yes in a way that I can sustain. Great. So as I see it, these are the challenges. And if I had to call out one of these, it would be the top one. You can read the rest on your own. But that's our PRP's major contribution is its removal of the complexity of the network system so that the problems we face are tractable. But then our tendency is to build that complexity back in again. And so we're unengineering our re-engineering. And that we really always have to keep that in mind. Keep it simple. Keep it simple. Keep it simple. And then hardware is easy, configuration is hard. So we struggle with managing this infrastructure in a way that is like everyone else. So missing ingredients, the big one here, I think we need some sort of federated identity management. And the rest you'll have to read very quickly. That's all. And ask me any questions when we have time. Thank you.
Hello again. Within EPSCoR, if you're familiar with NSF, you know that the newest strategic plan has been released for FY18 through FY22. And it's on a theme of discovery and innovation. So EPSCoR, in following with what the Science Foundation has laid out, you know, we are also looking at what are some of the critical areas that we would like to focus on. And one being, we think that the EPSCoR jurisdictions can be models for diversity. We think they can also be frameworks for how you partner with small and large business. And our third strategic focus is cyber infrastructure. And so we have some thoughts here, but we haven't really figured out what it is that we need to do as an agency. And EPSCoR NSF also is chair of the EPSCoR Interagency Coordinating Committee. So there may be things that you think about that NSF, NASA, NIH, USDA, and Department of Energy can do collectively to help support the National Research Platform. So I'd like to hear those thoughts as well. So we know that the face of research is changing. Geographically distributed user communities, and we want to be able to connect with people in remote parts of the jurisdictions. There are lots of labs, university, industry. Everybody doesn't have to build their own piece of equipment. They should be able to utilize something that's, you know, right in the state. There's an integration with other national resources and extremely large quantities of data. And now, just speaking from an under-resourced university, as Dr. Dent talked about yesterday, I was a graduate of Jackson State and had taken a networking class when I took a job at AT&T Bell Laboratories in New Jersey. I had taken a networking class, did well. They took me into the lab with the switches and the hubs, and I was like, well, what are these? So we want to make sure that students from under-resourced universities have access to everything that the other institutions have. So how do we go about building those partnerships there? And we've heard about some of the constraints on yesterday. And so we've started to think about what the ecosystem looks like and where do we play a role at? You know, we have expertise such as this in the room, tremendous amount of expertise. There are lots of organizations that people I've met. There are the scientific instruments that we support jurisdictions building. There's lots and lots and lots of data. And data interoperability continues to be a challenge in some cases. And the need for networking of all institutions and individuals for educational purposes, for research, and the software and the computational resource. So that's a lot. So I look for you all to help us find out where should EPSCoR contribute, where can we do be of most helpful. And so the path forward is, you know, looking at high-end computation data and visualization. Maybe we should look at those things. People who come to us for funding, maybe we should send them particular places for work instead of having them to rebuild. And so we have a lot of agencies and collaborations that we're really excited about. And the software tools, they're here, they're in different disbursements. So really, how do we connect, you know, what's needed? And so we've looked at networking, we've looked at data sharing, we promote that in the proposals that we receive, and we really promote collaborations. And as you can see, track 1, track 2, and track 4 are all about collaboration. So I need information from you, so I will step away so that we can get to the audience portion of telling us what we should do. Thank you.
Thank you, Loretta.
Good morning, everybody. All right. I'm Josh Sonstrom. I'm here from UC Santa Cruz, and I'm on this panel actually representing Brad Smith, who is one of the founding members of the PRP and is the PI for our all of our CC STAR grants that we've received over the past few years. I'm doing a lunchtime presentation, a deep dive on UCSC's kind of journey through this stuff. So I'm not going to go into too much detail here, just kind of touch on some high-level principles and things that we've observed. So first and foremost, I think UCSC's involvement in the NRP has been a big catalyst for organizational change. That's both within central IT and within our divisional academic teams. One of the biggest successes we've had has been the creation of something we call the CI Hub, which is essentially a multidisciplinary body of technical and leadership stakeholders. And these people are all committed deeply to bringing the cyber infrastructure that we have on campus into the hands of the interested parties, whether those are graduates, students, faculty, or staff. One corollary effect that we've seen of this new leadership model is that we've seen an emergent need for a new level of administrative control. The CI Hub was a great technical body, and we were able to make a lot of wonderful recommendations and set a path forward. However, what we didn't have is the political capital to make hard decisions, right? The things about the limited resources like the data center, power allocations, prioritization of things. So we really needed some sort of academic level political control kind of inserted above this recommending body to be able to make these hard decisions. One other thing that we've seen is the scaling issue. So as a central IT shop without any research support, we're faced with maintaining this project momentum throughout the year. And because my spare cycles as a central IT person are often during the summer, that doesn't align very well with many of our researchers who are often traveling during the summer or doing other things. So most of the core research that we see happens during the quarters. This has been a definite issue, but we're working on trying to solve it. One way that we've worked on that is migrating the science drivers back into the data center. So this has been a healing process for our campus. Previously, the data center was pretty tightly controlled, and there were a lot of limiting factors that controlled whether or not you could have power or equipment in there. We've opened that up and been able to bring back much of the engineering and research hardware into the data center over the past few years. And just bringing that in and that healing process of creating those new human relationships has been real powerful. So some areas for improvement I just want to highlight. One, we could use a dedicated, fully staffed science engagement team. Some people to go out and do the groundwork of reaching out to the individuals who are doing the actual research and bringing back their needs all the way to the core IT. More generally, formalizing a centralized research IT team for the campus to help close that communication gap. And this communication gap goes both directions, right? It's linking the needs of the last desk, the people who are actually doing the research, whether those are graduate students or lab assistants or researchers or professors, with the available CI resources as they're distributed now. Educating staff and advertising the available CI capabilities to campus clients. This is something we've done through web pages and small outreach, but it's difficult to get in everybody's head at once. So we're thinking about doing some larger scale presentations, trying to bring faculty and staff on earlier in their onboarding to get them aware of what resources we have available. We'll talk about a little bit of this more in my next panel, but UCSC was designed in the wake of Kent State. So there's no central place where all the students can gather. There's also no core to the campus. So everything's very distributed. And these college islands, as we call them, they have both physical and political differences. So bringing those all into a single harmonized system and trying to iron out some of those differences has been real important for us. And it's an ongoing struggle. Finally, education in the research and data carpentries, working with the library for data preservation, and encouraging additional local collaborations, which I heard mentioned yesterday, just so people can learn how to externally collaborate, right? It's real important that we have a fundamental understanding of how to work with others. Novelty, as you know, is a powerful force, and I don't mean to downplay this, but just like the cloud, I think data-intensive science applications like the NRP and the PRP, they're a disruptive technology, right? Just like mainframes going away to servers or servers turning into the cloud. I think some people are going to end up being left behind, making hundreds of dollars an hour supporting technologies that are 30 years old, right? Other people are going to come along happily. And if you can bring those people happily along, they're going to be excited and feel rejuvenated, just like Lewis mentioned with travel, right? Your employees are going to come back with new ideas, with fresh energy. So I think the Science DMZ, whether or not you have an extant need for it, it's often a really good opportunity to just bring these liminal technologies into the awareness of your staff and get them really excited about new things. And finally, I just want to mention that I think the PRP and the NRP are multiplicities. And what I mean by that is there's not just a single use, right? At its baseline, something like the PRP and the NRP is just a simple two-stage transfer system, a Science DMZ. But as you build on functionality and start to address the more complex pictures in science, we come upon higher order systems like Chase CI, right? That are not just looking at the first order of investigation into things, but actually looking at scientific research itself as a research opportunity. So I think it's interesting to see how the NRP is going to continue to shape these campus ecosystems in the next few years. And finally, as Manish mentioned yesterday, I think CI projects like the NRP face two types of challenges. First, from the side of innovation and first-order research with information technologies, there are classic problems, right? Maintaining project velocity in a collaborative environment, whether that's from one campus to another or from one department to another. Operationalizing the prototype phase of these deployments. So many times we get budgets for a one-off deployment or a proof of concept. Those get adopted. So then how do you work the funding to bring that into the productionalized phase? And then 3, managing the distributed layer 1 systems that comprise the network, compute, storage, and security that make up our cyber infrastructure. Then on the other side, we have our productionalized services, the day-to-day, ready-to-use services that are provided in supporting researchers doing their own first-order research. And for these, the challenges are slightly different, right? There's a clear need for human interaction on the ground and building these close, tight-knit human relationships so that we in the central IT can translate, again, the last desk needs into meaningful concepts that we can deploy. And my final thoughts here. So not all institutions will need a Science DMZ, but those that should, as we've heard from Jeff, should scale their deployments wisely, should look to meet the needs of your staff, but also to think ahead and plan for future growth. At UCSC, we've seen that a well-designed and deployed Science DMZ can act as a trim tab, helping guide campus research goals into a safe, sane, and productive collaborative conversation between all the required parties, whether that's security, policy, administration, or the researchers themselves. Thank you.
Thank you, Josh.
So hello again, I'm still Dan Stanzione, and I'm on this panel because Jim asked me to, and he was on the faculty at Clemson, and I spent years in grad school being conditioned to just do what they say and don't ask questions in that situation. So I'm here, and it has nothing to do with the fact that this meeting's in Bozeman, and there's been 33 days in Austin over 100 degrees already this summer. That's an unrelated fact that I just wanted to point out. So Jim asked us to maybe address a couple of questions here, sort of what's going on at our institution. I have a little bit different setting in terms of how we interface with the NRP, and then specifically to look at the question of how other campuses might be able to interact with national resources. So a little on TAC and then that, and then I just put up the picture of Stampede because I like it. And for no particular reason, I would say our big technical innovation, probably the primary one around Stampede 2 was try and figure out how to take those Dell racks with a mesh front and make them look good, as the water-cooled systems always have. I think most of you know a lot about TAC, so just one sort of, or maybe 2 slides of overview here. There's some new things coming, so we're going to get a little bit bigger, but we do have a wide variety of systems and services, ranging from the big leadership machines to, again, a host of experimental platforms to different things that fit more closely, a lot of emphasis on network through Learn. We do connect to PRP and now NRP. And I don't know why that little bit of text is on the side there. But
but certainly through systems like Chameleon, we're continuing to experiment in software-defined networking and how to build bigger and better flows into some of these resources. But we build them not for us, we build them for everybody. So we have a lot of storage, we have a lot of data caching, we can do terabyte a second I/O, et cetera, et cetera. And we do have tens of thousands of users and are always looking for more, even with the bigger system. And as was mentioned yesterday, there are more coming. I do want to say that we see this as yet another piece of the ecosystem in the larger system, and not necessarily a system just for a few elites, but as one of a set of systems that we use to enable science in all kinds of ways. And something that I hope you will still see in the new system is more than just a system. And those who've heard me talk a lot have seen this slide before, but as someone who runs a center, we've seen things change a ton over the last 10 or maybe 15 years. Broadening, I think Jeff mentioned, talking to humanists and other people, we have a much broader base of users. These users are sort of fundamentally different in nature, even biologists. 15 years ago, it was a safe bet that most of our users knew Fortran or C, and most of our users had seen a command line. And most of our users were primarily interested in simulating things that were primarily modeled by differential equations. And that is so not the case today, right, in terms of the user mix that we see. So if you came to us 15 or 20 years ago, we were the people on campus with the big cluster. So actually 20 years ago, I was at Clemson, and I was the person on campus with the big cluster. But as I did mention yesterday, we have more emphasis in data curation and web development and portal projects and things like that now than we do in hardware, even at TAC, right? So I have 30 full-time developers in the web and web services group at this point, which is much larger than the system staff at this point. So, this sort of broader notion of cyber infrastructure means that we have to have an ecosystem to support that. And there's the ecosystem we have at TAC, and then there's the broader national ecosystem that we're here to talk about. But part of that is the hardware resources. And, at the very largest scales, NSF will largely pay for those hardware resources. They won't pay as much for some of the other things that are on here, and in particularly the human resources. And by the way, if you're interested in any of these things at TAC, we have a lot of things that we can offer for free, where free is defined as somebody else pays for it. In this case, often the NSF. But the things that we can do cost recovery on, right? Data curation often falls in that category. If you want to take care of some data sets, that is something we can do. So we try and build our set of, both hardware and, software people services around this, but there's a lot left to do. So in terms of opportunities for the NRP, which is what I'm really supposed to talk about for the next 2.5 minutes, this is something I put together for the June NSF meeting that sort of is my feeling with proper intersecting zones of the Venn diagram for what the state of scientific computing software is today. We have sort of 4 goals that we ask people to do completely orthogonally. You should build stuff that we can reproduce. You could build stuff that's secure, so make it reproducible but never patch it. And secure and never patch it. Make it performant, and then try and actually get the answers at a reasonable rate without having to spend too much money on the other things. And I think if you look at our software projects, there's almost exactly 0 intersection between those 4 goals at the moment. So, and I think all the really good, interesting work happens at the intersections, which don't exist. So, I think, things that we can do, across a lot of campuses, there's a ton of talk. I like to say reproducibility is the current front line in the battle of the war on science. If you disagree with the conclusion, attacking the reproducibility of it seems to be a great way to undermine it in environmental standards or anything else. Best medical practice, et cetera, drug approval pipelines. And we're frankly vulnerable to that because we do a horrible job with computational reproducibility. And this is not a question that requires enormous scale to make progress in, right? There's so much work to be done in, say, machine learning generation of ontologies. There's tons of topics. But impact of data reuse, people are trying to count data citations. They're trying to say, well, did this data get used in there? There's a lot of impacts around having data that's shared that aren't easily countable that way. So I think understanding the impacts of having data that we can share, and then understanding how we can make our results better documented and more reproducible are things that every campus can contribute to, because figuring out how to do this better doesn't require scale or vast resources, but actually making it have an impact does require integration, right? So groups like this need to come together and push these good ideas out and promulgate them onto the big infrastructures for it to make sense. So you don't need scale to do it, but we have to work together and integrate to achieve it. And I think that's a key message. So when we think about the role of national centers in a platform like this, and I promise to finish very quickly, Jim, I think this is even the last slide. We focus perhaps too much on the physical infrastructure, right? That's what gets the HPC wire coverage. That's what we talked about yesterday. The single big investments, 30 million for Stampede 2, 60 million for the next one. But no matter how big those systems are, no matter what we do to make them more usable and how big they are, there's a thing I can't scale, and that's help down the hall, right? The big science teams that have 4 postdocs doing code optimization, they're going to show up and use our systems almost whether we do a good job or not, right? They're going to figure it out. But for many, many people and all of these new users, what they need is somebody who can help them use them. And it doesn't so much matter where they are. This is the whole cloud model, right? It's not where they are, but it's still bewildering. So the thing that every campus can do is help people get there, right? And so, when we talk about networking, I think that's one of the necessary conditions to enable this kind of remote work, but it's not sufficient all by itself, right? We have to move past the network and into these services. So I think for NRP success and future science success, it's the tightly integrated connection of people in addition to these national centers and resources. So, and I'll leave it at that. Thanks.
So I'm Dana Bronson. I run the research computing at Oklahoma State University and the Campus Champions program, which I'll tell you all about. We do have a really awesome HPC center at OSU. The first 5 years, it was just me. And then through community help and encouragement, we've built up to the magic number of 5. And we have a new cluster and it's all full, but I'm not going to talk about the research computing aspect of this at all. But what I do want to say is, well, the bad news. And I think everybody here hopefully agrees with this, not all campuses, but we don't have enough research computing or networking people on our campuses. We don't have enough collaboration between campus IT and research, especially where the research computing is not in central IT, and that's where we are at Oklahoma State. We're in the research office. And we don't have enough collaboration between the networking experts and the research computing facilitators. So, and then the other side projects are trying to do this with library and information security folks as well. So I am a recovering mathematician. And so that being said, I don't really like to solve just one little problem at a time, just at Oklahoma State. So I want to solve this for the whole country, if not the world. And I have proof on my ideas. So at Oklahoma State, like I said, I'm in research, and we have a central IT networking group that has zero interest. Well, it's not interest. They don't have time. They're overburdened. They don't want to deal with research. Their job is to make sure that people's email works. And so when I tried to get, any kind of networking bandwidth to my cluster, I was unsuccessful, except for we have this great statewide network, OneNet, and we have these weekly calls that we've had for I don't know how long, nearly 10 years. And so they listened to me complain a lot, and they got tired of it, so they helped me. And so I think this was when James was back at OneNet, and he helped, and he got me. We had a science DMZ like way back before it was on the ESNet website, I think. So current state is we have 100 gig at the border. We have multiple 10 gigs all to our research computing, and we're currently deploying 100 gig Fiona. How we got here is in 2007, when I first started, we had an NSF EPSCoR ROI Track 1 that Loretta's talked about, and it required a cyber infrastructure plan, and my friend over at the other university, University of Oklahoma, thought it would be a great idea if we shared all our research computing equipment with everybody in the state. And so we got to do that because nobody wanted to leave all that Track 1 money on the table. So ever since then, we've had this One Oklahoma Cyber Infrastructure Initiative. And this list of grants are just the ones that are even remotely related to networking. There's also, MRIs for clusters and all of those things. And the map over here is where we have our friction-free network from one of the first CCNIE, connecting all the PhD grantings, the HBCU, and the PUI, primarily undergraduate. So that was often Oklahoma Friction-Free Network. And then we did, when the small institution part of the CC Star came out, we were on a call and said, we should get all our regional universities to put together one for that. And so we had a workshop within a week, and they put one together, and that's more often. So that's the other 4 institutions in the map. And so we just keep having these calls. And then the next thing that's happened is this PRP and NRP excitement. And James moved up to GPN. And so I think this has been going on about 10 years too. So GPN has a cyber infrastructure program committee. So all the HPC directors in the Great Plains states, out there in the middle of the country, we are extremely lonely, right? So collaboration is in our blood. And so we've been on the phone together for years. And then when James moved up and got inspired by Larry's talk about the PRP, it's like, let's get that together. So for how long? Several months, if not a year. We've had weekly calls where we gather together the research computing people and the networking people and chat every week. And so here's kind of my proof, right? One Okie, GPN, these are demonstrated success stories of what happens when you actually do bring the people together. And that's what we've heard over and over in these meetings. So let's see here. So this is the great map. So it's all sorts of people, but we like get along. It's kind of weird. But we do have a culture of collaboration. We celebrate each other's victories. We tell each other stories about our struggles and our successes that we all learn from each other to do. And so the next step then is, we got the state. This is a good way to work. We have a region. That's a good way to work. And the next step is national. So I don't know, who's familiar with the campus champions? So there's a few that aren't. So I'm going to change that. So there's still kind of a disconnect. Like, this is my first NRP. I haven't been to too many real networking meetings. I live in the research computing world. And there's this whole group of people. There's close to 500 of us, and it's been going on for 10 years. And this is a community of practice, if you're familiar with that, where they actually share all the stuff they don't know and all the stuff they do know. And they don't have to be experts at every single thing in the entire cyber infrastructure ecosystem, because they can go out to the entire group and work together to figure it out. And so one thing that I want to kind of encourage here is that the NRP leverages this group who are already facilitating work with researchers to help use the network too. I think we do a good job with the computing and science gateways and those kinds of things, but there's still somewhat siloed effects between network and computing. So just to give you a little taste, this is the list of the longest threads from 2017. So lots of research, computing, data management, stuff like that. I want to see more networking conversations. Word cloud. We have Slack. We have an active email list. We also have monthly calls and bring in speakers. I'll probably be pinging some of you here to come talk to them because they are hungry for more networking knowledge and how to get in on the NRP. And lastly, this is them. So notice, these are our future leaders. These are our community around the entire country that can make all this happen. And so this idea of just getting people to talk to each other is a workaround for those initial problems I mentioned. But I think, thinking about what causes campuses to change, what causes them to put cyber infrastructure and all this into their strategic plan where they'll hire those people. Well, it's what do campuses want? They want more students and they want better faculty. And so what makes campuses change is the students go into the other campus that has those things. So as we help each other make these cases to our administration and make the students and the faculty demand them, then we'll build up the entire country. So that's all.
Thanks, Dana. So we got a little over 15 minutes for questions. I have questions if you don't. Can't see. Yeah. Is it on the
Hello?
bottom?
There we go. Dane Scow, North Dakota State University. I fully agree with a thread that I think I heard through every presentation, which is the hard part right now is the people. And the most desperate need of the people are these facilitator roles that we're all, it seems, recruiting for. I have a confession about life as a server hugger, in the sense that for me, at the small institution with a small staff, one of my concerns is that if we don't maintain the hardware presence on site, we won't be able to justify the retention of staff in order to fill the facilitator role. Because the facilitators are equivalenced in many administrators' minds with secretarial support. It's seen as coddling to the researchers. And I think we have to get over that perception. I think there are a number of challenges for recruiting for the small institutions that some of the, when you have large numbers, plus or minus one is not as much of a percentage change as it is when you have three, for example. But I was very encouraged to hear Dan's talk that there's no, or at least I may be putting words in your mouth, but one is that it looked like there wasn't an efficiency of scale in that facilitator role at the large centers. That this is a labor-intensive process. It is critical, and having 100 staff doesn't make people more effective at filling that role with more researchers per person when you've got a larger staff. So my question is that true? And does the panel have any advice or insight into how we can collectively make the case that this is not the same as having a secretary take dictation?
I'll take a stab at that first. So to address your question about the need and the perception of need on campus, I have found it very helpful to have the faculty themselves, with maybe a little nudging, express those needs. So when I went to, thankfully, I'm blessed with great leadership in our IT organization and a nice, healthy relationship with the faculty. And when we started to have the discussion about, well, we really need a research facilitator on our campus, the faculty quickly volunteered that we want our research facilitator to look like us. We want somebody with an academic background. They expressed an extremely strong preference for someone with a PhD in the sciences, who had built scientific workflows, who had felt the pain, who know what the priorities are, publish or perish. And so in that way, there's no way that our campus leadership could construe this person that we want to hire as a secretarial or administrative position. And maybe that was a lesson learned from the fact that my HPC systems administrator last year had been accreted to the union for administrative staff in the secretarial, vein. So, what's in a name? They just saw, administrator and thought, oh, well, this person is a support person in administration and they should be in the union. So we were very careful to construct this position in a way that was responsive to the faculty's demands of a peer, or at least a near peer.
So if I could build on that a little, Jeff. You said what's in a name, and I think a lot, and I don't think facilitator is a great name, frankly, for the problems that both you and Dane both mentioned, right? I also hear, right, what your faculty said was we want somebody who sort of looks like us, right? But I don't think there's a lot of people in graduate school in the science and engineering now who want to one day be a facilitator, right? What they want to be is a research scientist engaged in multidisciplinary and transdisciplinary work, which is what they are in these roles, right? So I think, we undersell the role. Most of my people who do this kind of work in our HPC and data groups are in the term, titled research scientists, right? Because they do part of the research, right? What we do in CI is a part of the research process, right? And it's it is a significant intellectual contribution to figure out how to take the science and make it work in these things. And it's essential to getting the answer, right? So, I think, Dane, to your point, it is hard to get the title facilitator funded, particularly at the salary that will attract a PhD. But every campus knows what a research scientist is.
I could add a little bit to that too. And you can talk to Tom Cheatham, who's here, or Dana, about a professionalization effort that's going on. NSF has funded at least 3 workshops that I know of on professionalization of this facilitator role. I agree, it's not a great role. One faculty member told us on a site visit the term that he used, which everybody gets it right away, was research concierge, but the facilitators hate that one too. There's no ideal. In Europe, they call them research software engineers. But there's a concerted effort going on now in this consortium that I mentioned to really move towards professionalizing, and NSF's very interested in helping with that.
Yeah, and I would second Jeff as well and just say, our research facilitator who's sitting in the front row here, Xia Feng, is exactly that person, a teacher type with a PhD background in the same sciences that our groups were looking for. So the other thing I would say is that if you can get another CIO or someone in that kind of role to speak to yours in their own language about this term, someone who is already research oriented, you might make a little headway that way. That's kind of a quick way to get the boot going down the road.
Sharon?
So in my usual fashion, I'm going to both agree with Dan and disagree. I agree the facilitator name, and I've said this to Jim before, it sounds a bit as if faculty and the other people are in confrontation. But back to the research scientist, I'd be very careful with that because in many institutions, and that includes mine, a research scientist, A, is only on soft money, and B, is also doing their own research or doing one group's research. So at many institutions, including mine, any kind of this task would never be thought of as a research scientist. But I would like to not just disagree. My idea, which many of you have heard, is that in many organizations, it makes sense for everyone who is doing any kind of work in cyber infrastructure, research computing, whatever you want to call it, to be capable of doing this facilitation. When we hire people, we only hire, even if they're sysadmins, we only hire people who can actually talk to researchers, who understand that they're part of an organization, and basically do not think of themselves as facilitators, but do the work.
So one thing in the professionalization workshops that we've been doing, especially the most recent one with the CAR, Campus Research Computing, we were very careful not to use any job titles whatsoever, right? Because if you want to get anything accomplished in this community, you really have to stay out of the weeds, as impossible as that is. But what we did is try to make, this workshop came out with an actual deliverable. I know you'll be surprised. Sorry. But it's kind of a job families guide, right? Because we tried to look at, we had social scientists and folks from HR in the room to try to talk who have experience with, professions as they come from not existing to becoming their own discipline, and had lots of discussions about what it is this community actually does, and came away with being very modular, because it very much depends on if you're a research computing center of one, you might do everything in the whole document, whereas if you're at TAC, you're going to have much more specialized roles. And so the way we developed the framework was to look at what the person faces. So we have the researcher facing roles, the systems facing roles, say the institution, stakeholder, sponsor facing roles, and then kind of data and software facing roles, and develop these types of things. And I think as we can socialize and improve upon these sorts of documents and get some sort of consensus across the community, it's going to help us at universities to get those jobs, whatever you have to call them at your institution, but help us get salary ranges that are going to be able to attract and keep talent, and various other issues like that. But I think, this community is so different than so many others in that, most of us have come into this from very idiosyncratic ways, right? How many people are computer science trained? A few, but certainly not everyone. And I think we like that way. We love the diversity of perspectives that come into this. So as we look toward professionalization, we want to keep that in mind and make it a very, 21st century concept.
So, Sharon, about some of your points about the research scientist title, that's true for us too, right? It's soft money, and it implies a certain level of research productivity. And there's a review of that periodically. We do, for people starting out, we have some other, similar titles, engineering scientist associate, research associate that we use, but everybody wants to get promoted to research scientist out of those sooner or later. And I mean, I've spent my whole career in soft money, so maybe I just don't think of this as a bad thing. Little known facts about TAC. Steady state base funding, before Jay started adding NSF funding to it, there were 9 staff, and the base funding is the same to the dollar, not even inflation adjusted as it was 17 years ago. And so at this point, we're 92.5% soft money. So, if you are being productive and helping people get research going, eventually you get attached to their funding one way or another. So, I expect our research scientists to be generating some funding, and I expect them to publish with the people that they're working with, often multiple teams, and build a productive and contributory research career in this. Heck, until they added the vice president title, I hadn't ever taken $1 of UT salary out of base funding until last year. So I was 100% grant funded all 5 years I was at ASU, and then the first 8 years I was at TAC. So and granted, at this point we have some structural advantages in that, no doubt. But still, the research computing budget at UT is below $2 million. So, which is probably lower than some of the institutions here. So, and everything else is soft money and building partnerships with researchers one way or another. So I think those constraints are real that you mentioned, that it is soft money and it expects that you write a report to the provost periodically that shows your publication track record and stuff like that. I'm not sure that's inappropriate for these roles. Again, we start them in the associate title. So for the first 4 or 5 years, there's not that expectation, but as they build up, if they're being effective, they should be part of people's projects.
Mm-hmm. Jim Pepin's got a question.
So Jim and I have worked together for a long time, and what I've seen in the last 40 or 50 years is cycles. Cycles of administrative, cycles of research computing. And one of the things that's very interesting, looking back at the places like Clemson or USC or wherever I've been, is eventually there reaches a tipping point where something, either it's administrative computing or research computing, becomes too controversial, or it's viewed as taking too much resource, or it's viewed as being eating somebody else's lunch. And I think what we have to be careful of as a universities is not to go to, is to moderate those extremes. But at the same time, at least at the public universities, the funding crises that are going on are creating a thing where the plumbing has become far more important than the things that will leverage you and get you someone to get a Nobel Prize. It's more important to get payroll checks out. So I worry about this. I'm 70, I'll be 70 shortly, and I'm going to retire and have, a place in a box canyon with 2 machine guns. But at some point, we have to think about what the future.
You should really be in Texas,
in the right
California,
place,
Jim.
Yeah.
At some point, we have to think about what our universities mean to the country and to what we're doing. I'm babbling, but I worry that there's these inflection points at universities, where you bring in a president who ran an oil company, or you bring in a president that did something else, and I just worry about that.
So I think that's a really legitimate concern, Jim, and that is one of my concerns in places where research computing is aligned completely with IT instead of, so I report to the VP for research. I'm associate VP for research. So Dana's in the research organization, but a lot of them are in the IT organization. And yes, eventually, right, things that get squeezed are things that are sort of optional. I do think it represents a certain lack of vision by leadership to be attached to the things that are only costs and not the things that can help bring in revenue. But as you know, done well, research computing drives research dollar growth. But I think living entirely in the IT organization makes you very vulnerable to those types of things. And yeah, I see the same thing at UT, where everything that's not critical gets squeezed out by the budget crisis of the day. And you've been at Clemson too. You know this. I was there when Hurricane Hugo came through. And so, we're on the 30th consecutive bad budget year, right? There's just only one kind at this point, right? It's the standard adage that faculty morale is always at an all-time low. So
one more question, Frank.
So as a faculty, I am somewhat allergic to my colleagues asking for, I want this for free, I want that for free, I want that for free. Because when everything's said and done, all those freebies are paid for from IDC, and IDC has only gone in one direction.
Yes.
And that's up.
Also for 30 years.
Yes. And quite honestly, I'd rather pay for the things that I need than have them commingle completely in IDC. There are exceptions to this where you can clearly produce incentives in order to avert absurdity on campus, like balkanization. So there is a reason to have power being free for me, because if it wasn't, then it would be a very weird incentive structure. There's a reason to have space be free for me. I'm not sure there is a reason to have facilitators be free for me, because when everything's said and done, they are so close to my research that I should be paying for them.
I think we're out of time. Can we have a appreciation for the panel?